Well, good morning, everyone. Welcome to the first session of the event. I'll be talking about mobile game development with Unreal Engine, more the platform side, no real rendering stuff, though I will mention some of the new features. Now, who am I? I'm the mobile platform programmer for iOS. That's my primary platform I'm responsible for, and that also covers things like tvOS, iPadOS, a little bit of visionOS, and I do help out on the Mac when needed. But though for the last month or so, I've been helping out getting the Fortnite iOS release done. So been a bit sidetracked, not doing as much engine work as I probably should have been doing. Like I said, iOS. And I've been a game dev for about 20 years now, about 12 published titles, but I always enjoyed doing engine stuff. So having a chance to join Epic was amazing, so I can actually just work on the engine stuff. I'll be covering some of the updated 5.6 features as it relates to mobile specifically. So there'll be like no discussions of Nanite and all the new stuff they have. A couple of new 5.6 and some workflows for mobile development. So let's go right into the new features. One of the big ones, and this is more for artists, not so much for developers, code programmers, is the preview platform. This allows an artist to change what's being rendered on the level based on the target platform that you want to do it. So whether you want to do an Android Vulkan, or a low-level metal device, OpenGL, and you can actually also do other platforms, other console platforms if you have a license for those. Just as an example, this is the default, this is running on a Windows machine. This is your default SM6 level. It's one of our test levels we have for mobile validation for rendering artifacts. So this is plain PC view. Vulkan High, looks pretty much the same. The bloom is a bit different on this. The sun's not as defined. The texture quality is a little not quite as nice as the PC version. And how do you know it's running in the Android? It, of course, says on the bottom the specific platform that's being previewed. And Vulkan Low, much lower resolution. This is your really low-end Android devices. No lighting, not great shadows. Texture quality is way down, but it allows you to see if your level will render correctly and looks decent on a low-end Android device. And like I said, for Android, they also support OpenGL, not just Vulkan, but we are moving more to Vulkan than OpenGL. But as OpenGL is always, there's a fallback. That's Android. How about iOS? iOS doesn't look that much different between the high and the low levels. The metal is just a bit more capable, and they do refresh devices a lot. And as, again, I am an Apple platform guy, so I am probably a bit more biased on the Apple side. The hardware is great, and you know what you're going to get. It's a lot easier to support iOS due to the limited number of devices. Android, we have thousands and thousands of combinations, and it makes it really tough. So anyway, but the low side, go back over here. The texture quality has gone down quite a bit on the low end, but does show most of the features available. And this is running on Windows, so again, you can do the preview on Windows, but it also does have the same support on a Mac. So if you're a Mac dev, like me, it is handy being able to test Android, iOS. You can even test PC if you want. How do you do this? Well, it's very basic, very simple to do. You just have to go to the new toolbar layout that they have. They've added for 5.6. I think it's really pretty, and you hit on this thing that to me looks like a speedometer, but it's the performance and scaling button. You press that, and you can see that for this one, not that one, you can list your default Android. You have your high, your low, generic. If none of those match what you're actually targeting, you can specify your own JSON file with the settings you want. And you can do that through this one over here, the generate platform JSON. So you could actually do some different platforms if you wanted to. And then you also have iOS, has the same one. There's been some debate, the naming scheme, some people aren't exactly happy with. Generic iPhone 6s and iPad Pro. We're probably going to be renaming those to low, medium, high. Or in this case, medium, low, and high. As those being more representative. And if you have licenses to other platforms, you'll see them in here in this black area here. Of course, there are limitations to Preview platform. It's not perfect. One of the biggest ones is that it cannot emulate hardware-specific issues or driver bugs. Android drivers are constantly updating, and we cannot, if you have this strange Samsung device running a 5-year-old driver and you want to emulate it, you can't. So it does its best case it can to emulate the Vulkan. Next one is you can only preview a single platform at a time. It does take time when you switch between different platform previews. It does do a shader compilation. The only it does it once, so you don't have to do a shader compile every single time you switch between the different previews. Of course, it'd be nice to remove that, and there might be some discussions happening to maybe show more than once, but nothing happening anytime in the near future. And this is an interesting one. You can't replicate a target device with a lower-end system platform. So in this instance, I show if you have an M1 Mac, it doesn't do Lumen. Well, not a good one. It doesn't do Nanite. So you can't simulate Nanite on a target device if your underlying platform doesn't support it. So you probably want to use a high-end development system, maybe an M3, M4, or a Windows machine, as those support everything, to do most of these platform previews. Now let's get into simulators and emulators. There's been quite a bit of few changes in this area for 5.6. Let's talk about Android. We've integrated Android emulator into the editor, which is a great feature. You can now it just shows up as a device. You click it, and it will do a compile. And the APK is the same APK you would basically have on your own device, on the Android device. It can be automatically installed, the emulator, when you set it up on a PC. And it actually does work, mostly, on a Mac OS, though there might be a hotfix coming out some time that might improve that a little bit. As I said, the emulator does appear as a device, and I'll have a picture of that in a bit that can show you what that looks like. It will show us offline until you select it. And then you have, and that's the new integration. On Windows, it can run ARM64. But we also do automatic package for x86 just because it's a bit faster when it's emulating it. But as always with all these devices, these emulators, you cannot trust it for performance. So it may run amazingly fast on your PC, but it may not run as well on your actual on-device. Setup. Just to quickly do that, you do the Android. This is a fresh install, you'll see over here that I am missing Android Studio is not installed. You do have to have Android Studio installed. So you select that, the full install, and it'll pop up with a turnkey message saying, hey, do you want to install it? And if you say OK, and it installs it. And if you're lucky, you end up with new devices listed. It is still new, and it may not be perfect, but in general, it does work well. By default, it just creates the medium device here, Android device. Although I've also seen it create a Pixel device as well. And this is, so the emulator is not available until you go through this process. But it is almost mostly automatic. And like I said, it does work on Mac and Windows. And this is showing it with another Android device, a Pixel and a medium Android. And then this is it, showing I just selected both emulators, and it popped up. I did have to rotate the screen, so it was in portrait by default. And you go in landscape, and you can see you have a Pixel and a medium, and they look the same. This was the older 5.5 template, third-person template. The new one's changed a little bit since then. How about iOS? Well, it's nice that Android's supported, both on Windows and Mac. We still can't simulate iOS devices on a Windows machine, so if you're doing iOS development, you will have to use a Mac. But we do have the iOS simulator, which is the one that's built into Xcode. And that's been there since, I think, 5.3, 5.2. And just as a reminder, you would just select, it would show up in the simulator section of the platforms menu. And it would automatically install it, you hit the thing, you rotate it, and it's running well. It really hasn't been updated in a while, and it has some issues. So we are deprecating the iOS simulator for something else that's coming up. It only emulates Metal on A8 devices or less. So all the neat new features that you have on the A12s, A13s, we can't support those due to the limitations of the simulator. You'll actually know if you want to use a simulator, if you go into the iOS project settings, you'll find that there's one that just says support A8. And that is purely only there for two reasons. One, the simulator, and the other one is for an old tvOS device we still have to support. If it wasn't for that, there would be no button. So if you do want to use the simulator, you do have to enable it, and you lose all the features you would have on more advanced Metal GPUs. It requires a custom binary build of every static library. UE ships with dozens of static libraries that you will link into your program. We have to create different libraries for iOS, tvOS, visionOS, or have their own libraries. We also have release and debug versions of those, so you're up to 6 libraries. We also have simulator libraries, so again, 3 more of that. So we have 9 different libraries for every Apple mobile platform, which is getting a bit difficult. We do have tools that help automate it, but it's still not the best, and we do LiPo some of them together, so it does shrink it down to just one shared library. But it's still a lot of work trying to keep these things up. So like libpng, we have almost a dozen versions of the same library just to support the Apple platform. It does require custom shader compilation. When it does do a build for the simulator, it has to create its own specific shader Metal libraries, and that can cause problems. If you look, you'll see it has like an underscore iOS sim. And that is the library specific for the platform. And it's not perfect. It uses Mac pretty much as an underlying base, and it has some visual artifacts that can cause problems. But there's another solution. Well, obviously, yes. Apple introduced a new feature a few Xcodes called Design for iPad. And that is what we're enabling moving forward on. It will pop up. I think it shows it here. No, it doesn't. If you go to the Platforms menu here, it'll show up as a Mac Design for Platform. And this is what it looks like. By default, it's iPad. To enable it, if you have an existing project, 5.6, you have to go to Generate Project Files in the terminal, or just go to the Tools menu and regenerate it, as it requires new platforms added to the xcconfig file. Then you build Cook Stage with the editor, you use one UAT. I'm showing my bias here. I'm a terminal guy. I do pretty much everything from the terminal. I probably don't use even though I compile the engine probably a dozen times a day, I spend most of the time in console land here. And I use Ushell, and I will be talking about Ushell a little bit later on. If you don't know Ushell, it's a great tool. Then you just open up xtconfig workspace, select, you can do it, this is doing it from Xcode. You select this, and you'll see a new option, designed for, this one, it should say iPad, this is iPhone, and I can explain a little bit why that's different. You press run, and then you suddenly get the screen. But is there an easier way? Yes, as I mentioned, there's just a new item in the platforms menu. And that will disappear automatically now with all new 5.6 projects, which I expect most people will actually use. How about iPhone? Well, it's great, it's on iPad, but iPhones are our main market, not iPads. So you can change it to design from iPad to design for iPhone. As I was saying, you have to basically just go into the project settings, disable iPad, and it will show up as a portrait screen. And it will say designed for iPhone, not designed for iPad. We don't have much control over that, other than we disable compiling for iPad. Of course, it won't work on iPad from that point onwards, so it's up to you what you want to do with that. Limitations, pretty much the same limitations as all other simulators. It's still running in a Mac. Metal is still not a perfect emulation of what's actually on the device, although Apple has been moving it much closer together, so you will get a very similar match between them. And of course, true performance. Your Mac is a huge CPU, GPU. It may do amazing multi-pass rendering with tons of lights, and then you run a device and it runs at 2 FPS. So again, always test on the device for true performance. And touchscreen. Well, you can't really test touchscreen. It's not easy to do. So if you're going to use it, you can use a keyboard or you can use a game control. Those are usually the two I use. And this here is something different that's new. I'll talk about what this strange D setting is later on. That's part of a workflow coming up. So in summary, Android has 2 different ways of techniques for test with our device. And this works on Mac and Windows, so you can do the platform preview or the Android emulator. I find the emulator starts up really quickly, like a couple of seconds, so that's probably be more my recommendation, though if you're doing a lot of stuff in levels, the preview is very handy. And it's also easier for artists, not having to worry about having all the Android SDK installed and all that great stuff. And on iOS, we have 3 different versions: the deprecated simulator, platform preview. Although this does only work on the Mac, it does not work on a Windows-based machine. So obviously these pictures were taken from my Mac. And this is another picture of them. In summary, the simulator, designed for iPad, designed for iPhone. Does it actually show? Yeah. So, yeah. And then we have, demo. Let's see if this works. All right. So a quick one here. I have the new, one of our new templates for third person. As you can see, this is just already done most of the work. It's a bit more colorful than the old one. If I go to, let me just escape on that. If I go to platforms, you can see on the iOS, I have my iPhone connected, and there's the new design for iPad. So if I select that, it will do a full build, which this is a 5-year-old MacBook. I do use a Mac Studio back at the office. It does this in seconds. I miss it. I wanted to bring it with me, but I couldn't. So this is my backup laptop. I really recommend the Mac Studio if you're going to do any iOS development. It's an amazing device. Or Mac Mini works great too. So it does do the full build, cook, and deploy. Oh, that's working. And eventually, it will. I'll show you a much faster way of doing this in a second. I just want to do this to show you how you can do it the official way. One of the workflows is the way most people probably do it. Even though it's not doing anything new, I've already pre-compiled it, I've already pre-cooked it, I've already deployed it, but it does go through the entire sequence. If you're doing it from a terminal, you can just hit the, let's start it up. Oh, nope, didn't start up yet. All right, you can just go do a straight deploy and run, and that is much faster than doing it through the editor. But if you do changes to the level, you're putting in new assets, changing a texture, then you have to recook it, so you're pretty much going to be doing it this way. And it will work eventually. So still doing the cook here. It's signing the, if you're always wondering what all this stuff, I can explain to you what every line here means, if you want to know. This is just re-signing it over here. Where's my button not working? Oh, I picked the wrong. Oh. And this is it. So you got design for iPad here. They said this is just my mouse. I can run around, do great stuff, and it will look pretty much the same as on device. Let me just kill that. Let me just go to Xcode here and do the same thing. Just hit run. Again, you can select it. Again, it will show up as on device or designed for iPad. Hit play. And there's even a faster way to do it than this. It still goes through the build, a lot of the same procedures. So it's already done the build, now it's launching it and deploying it, and it's deployed. So again, much faster through Xcode. And if you want it within a second or two, you can also just hit Control, Command, Run, and it will pop up right away. That just skips everything. So anyway, that's the new design for iPad, iPhone. Again, you just disable the iPad if you want the more the portrait format. Lost my mouse. All right, this is also I thought it was resizable. Nope, it's not resizable. Okay, so that's that one. And there's no Z symbol down here, which again will be coming up in a minute. Let's go to the presentation. Yep. All right. All right, GPU rendering updates. We have an amazing mobile rendering team that's responsible for all the graphics on mobile. They're not here today, but I have a general idea of how it works. We do have lots of rendering guys downstairs that can help out if you have specific rendering questions, and I might be able to help, but it's not my strong point. So, deferred chaining improvements. We now use 128-bit buffers for the GBuffer. Memoryless is becoming what we use. It helps reduce trashing on the memory for the TBDR, your tile-based deferred rendering, which is all what mobile chips use. Android GL, they use mobile forward. But for now, for Fortnite, we've pretty much switched. Let's see, right here. Multipass deferred also uses another portable consoles and PC performance modes, so Fortnite uses that for its PC performance. We do have experimental multipass deferred supporting that works better on some Android devices, but only a few. It's more of the advanced features, and more information is coming out about that probably in a future release. Fortnite now uses mobile deferred by default, but you always have, and the engine default is mobile forward, so you always have the option to switch to deferred. It's with the recent release of Fortnite, iOS has had a little bit of tweaking, and it's now very stable. So you're welcome to use mobile deferred rendering. GPU scene has been enabled by default since 5.5. They've added some new features, 5.6, as it shows up there. Skin mesh support. If you wanted that before, you couldn't use GPU scene. And Niagara mesh particles, if you want to have some pretty particle systems in your iOS, Android device. And there's been lots of tweaking to it and lots of bug fixes. It's definitely a lot more stable. Additional GPU, Android pipeline state object pre-caching. They use a separate worker process now to do the compilation offline, well, on device, but not blocking the main thread. So that helps get things going faster. I use IPC to transfer the information across. iOS, PSO, same thing. Lots of tweaks and improvements for 5.6. But the big one is that we now memory map the metal libs. So it frees up more memory. We're always after more memory. We never have enough memory. So anything we can do to increase the amount of memory, freer memory available for the program is great. So memory mapping those metal libs, which are, depending on the project, like 100 megabytes of data. Like it's a huge file. That's nice not just to be able to memory map it and not actually have it loaded in memory. Other ones, lighting model, change to match the desktop renderer, mobile-friendly screen space reflections, and debuffer decals, which I know some people were missing because I had quite a few requests for that one, wondering why it wasn't working. And then skylights, support skylight real-time capture. Again, these were done by the mobile rendering team. And what went in recently was experimental DFAO, your distance field ambient occlusion. And that's experimental. You can enable it with a CVAR or not. And just to know what it looks like, this is an example of no DFAO and DFAO underneath. You can see that there is a shadow up there, no shadow up there. It blocks the skylight from causing issues with the corner shadows. And that's what I see anyway. And there's some other stuff in there too. Shader platform, we did to enable more features in the future. We did refactor some of the enum names or the defined names. Like for example, let's go back one here. SP metal MRT, well, that's kind of generic. What happens if we have a SM32 in the future? Well, we can't just call it metal MRT. So we're now being a bit more specific with what it relates to. SM5 is still the standard that we have. And each platform, tvOS, Mac is now a bit more specific. They also have an SM5 and an SM6. And just general metal is just ES, it's not OpenGL ES, it just means the features are similar to OpenGL ES on iOS. And that's just again, so we can extend it in the future for new stuff. We do support cooking iOS shaders on Windows. Now, I'm sure you've all heard of Horde. Horde's our giant build system, which we use to build our giant projects. We have so many shaders on Fortnite that a Mac runs out of memory trying to compile it. So we had to support Windows. So we have Windows machines that do all the shader compilation, all the combinations, all the permutations of those shaders get compiled out in the cloud, and it works great. So the source is sent off to our Mac build farm and compiled, and all the cooking is done on Windows machines. And that is how we compile for Fortnite. Apple did release some new Mac Studios with 512 gigs of RAM. I really am tempted to try compiling it on that. Maybe one day we'll actually be able to use a Mac to do the entire compilation. But for a regular size project, a Mac can do compilation fine for cooking. There's no problem with that. So to install that, you just have to install Metal Developer Tools for Windows on your Windows machine, and it should be mostly automatic. Though we'll probably need some settings in the iOS settings file to actually make that happen. Now, this is the Mystery Z I was talking about. Zen streaming for mobile. This is, I'm sure, how many people have heard of Zen streaming, or Zen in general? All right, so it is fairly common, all right. So, trying to install 30 gigs of data to or 25 gigs of data to a device for testing get slow every time you want to test a new asset. So this allows us to deploy Fortnite onto an iPhone 16 Pro using a USB 3 cable. Don't use USB 2, otherwise it'll be a 30-minute install. We can get it down to, I timed it about 27 seconds to go from install, like just installing onto a fresh device, to seeing something on screen, which really does help the dev loop iteration a lot. Most people won't have the extreme asset requirements of a Fortnite, but it's still, even for Lyra, it can make a huge increase. Again, you get down to like a 20-second install if you use end streaming. And it also helps a lot with consoles too, if you have access to those platforms. To use it, setup, pretty simple. You can always look at these slides later. You saw it's one setting in the settings. It's called Enable Zen. You enable Zen, and it will stop as that. I'll show it off in a bit on a quick demo. And it will just send all, instead of being packaged with your app, it'll be sent off to the Zen server and stored on your Mac or Windows machine. And then when you install the client, there's a file that says, go talk to this server. And then as soon as it starts up, it creates a connection to the remote server and then starts streaming the assets. They did add caching, so it only has to really cache it once. And then it'll bring in new changes as they push to the new Zen server. So most of it is actually, once after the first install, most of it is still available on device. So you don't have to re-download it every single time you start up the app. Oh, I have a demo. All right, so for this one here, I'm gonna go through this slow process again. To show up Zen, it's easy, go to the settings, select Zen. There you go, preferred outlets, output store. Actually, I plugged it in with an Apple device. It resets the IP every time. Oh, sorry. Let me unclick that so you can see me press the button. All right. All right, so we're there. So you type Zen into search, and you see a button, enable it. You press that, and now you have Zen. Simple as that. But you do have to do a full recompile. And since I will have to do it again. And since I want to be, it's not as reliable going over the, I've got my USB 3 cable, so unless it'd be like a 10-minute install. So I'll just do the design for iPad. I'll go through the system. It does package it up differently. It still cooks. Oh, I should bring up the dashboard so you can see it happening. All right, so let me just zoom in on that. All right, so this is the Zen dashboard. Let me just reset that because we won't see it otherwise. All right, so you can actually see the numbers change, which is usually half the fun. Down here at the bottom of the editor, you now see something called the Zen server. The check mark is nice. It tells you if it's running or not. Launch dashboard. I didn't know about this. For months, I would use a terminal to launch Zen dashboard. Until someone told me, why don't you just click the button at the bottom of the screen? It saves you a lot of time. So hit the button. That will start up this Zen dashboard here. It has a lot of information in it. And you can see it was 0 before. It's basically checking. I have recompiled this before, so it's not really doing any writes because, well, it's already in the cache. And did it start? Let me just unzoom this. And did it start up yet? Oh. And that's not letting me click on it. Okay, is that actual backup? All right, so that's up. It's still deploying to the design for iPad. I should have turned off the iPad settings so you could see it as an iPhone. And it will connect. Launch complete, starts up. Now this is running with no assets bundled in the package. It is connecting to the Zen server to do it. Now this is on a local device. It works just as almost magically with a cable or over Wi-Fi. or Ethernet even. Consoles use Ethernet, so they have to use that instead. So the Zen here, it will show you have a connection. It will show you the speed of it, how much data is being downloaded. So it's nice to see that you actually have it running. And it's also really useful because it's amazing how many times you run the app and suddenly you get a black screen. You don't know what's going on, and you forgot you had enabled Zen. And it's trying to connect to a server that's not running. So that's also very handy here. And it's fast. Over a USB-C 3 cable, I've reached up to like, I think 20 gigabits per second connection. So it does really copy it over really fast to the device. And it's a lot faster than copying it. It only copies over what it needs at the time. It doesn't copy everything over, only on demand. So it's much faster. But again, it depends on the size of your project. If you have a smaller project, you may find Zen to be more trouble than it's worth. But we are using quite a bit in that case. And the same Z shows up on the iPhone too. Though just as a quick note, if you are using an iPhone, you plug it in, restart, wait 20, 30 seconds, then restart Zen. Because the private network that Apple creates between the device takes about 20 seconds to reset, and it's a different IP every single time you change the cable. So you can't use a fixed IP for that. We will be improving that. All right, back to the demo. Look here. All right, oh, and the other thing too is, yeah, that's good. All right, let's just go back to app extensions. This is iOS specific. Android has its own version, but that works a bit differently. What app extension? Well, they're basically Apple's plugin system for iOS. You want to enhance your notifications, that's an app extension. I have some examples on the next screen. There's like 40 of them now. It seems like every iOS release, there's more extensions being added. These are just a sample of some of them. And you can scroll through the page quite a bit. There's like a whole bunch of pages for that. Adventure 45. And it's the Apple's only way to get access to system features that you might want in your app. Some examples, home screen widgets. That's probably the most, well, actually notification one's probably the most common one. Everyone wants to have a home screen widget. You can imagine having what friends are connected, what's your current score, what's the high score table for your game. Another important one is background asset downloading. If you're using the Epic Store, you don't have access to ODR, on-demand resources, so you have to download with a separate plugin to do that. And as I said, notification, you can download an image and show the notification. You can change the entire layout of the notification. And that's done through the notification layout extension, not the notification service extension, which is the one that you can modify, just the text or the image. It does have some requirements. If you're using it's only 5.6, you have to use modern Xcode. If you didn't know, we have a legacy Xcode build system and a modern Xcode build system. The modern Xcode build system, there's a talk about it. If you want to know which presentation it was, just come see me. I'll let you know. It's done by Josh Adams. It's a lot more closer to how Apple builds iOS apps than our own custom system. You have to use Xcode to create the initial app extension target. They stored under your project build iOS extensions, so you can have all your extensions in there. It will scan them and update the configuration, the Xcode config file to build those. And on device, they will be under the plugins directly. Like I said, Apple is Apple's plugin system. We currently only support one notification service extension, but we did add a lot of work in to get that in, so adding more extensions will occur in the future. So this allows you to download an image, modify the message, or just ignore the notification, or create a task to occur at a later point. So it could be a silent notification to do something to your app. It's probably one of the most simplest plugins, which is why we started with it. It is these extensions are separate binary applications that are bundled with your app. So instead of a .app, it's a .app.ex. So it's a totally different target that you have to build within the system. To do just go through this quickly, you just go to Xcode, target, select, you create a new target, you select the extension you want. In this case, notification service extension. Need to automate this more, but you have to copy the created target into your build iOS extension directory. And then you have to generate project files since it does update your project configuration. And the source will appear in the primary project location on Xcode. Or you can just go to Editor, Tools, Rebuild, Configuration. Debugging it, every extension is different. How in this case, you basically just plug in your device. You say attach your process, the name of the target you gave it, and you say attach, and it'll just sit there waiting until the binaries is activated by an incoming remote notification, and the breakpoint will hit, and you can then debug your extension that way. Not the best way, it's a bit convoluted, but that's the way it is in this case. And it's pure Objective-C or Swift code. We don't really support any Unreal framework libraries inside these extensions yet. Ushell. As I mentioned, I like terminal. Ushell is great. Anyone here use Ushell? No. Okay, so it's a terminal-based command line interface. I use it for, I use tmux, and I have like 5 or 6 of them all active at once. I switch between them, different repos, doing different things. And I say here it works on Mac, Linux, and Windows, even Windows, command line. And it can be faster to run and deploy. It's nice because if you run an iOS project through Ushell, you get the console output right there. So it makes it a lot easier. And this time you can .run game iOS, and 2 seconds later it's running your console. It's better than hitting platform, device, run, waiting for it to build, cook, deploy, run. And like I said, it does everything, build, cook, stage, deploy, run. It can even package for you if you want. And it is bundled with the 5.5 and 5.6 under the Engine Extras directory Ushell. And it can be customized for your project. We have tons of extensions internally that do things like you type in one command and it starts up a server, a matchmaking service, a client, it starts them all up, runs everything. So it's a lot easier to do everything. It's just Python. So if you like Python, that's what it's used in. And there's lots of documentation in the README file in the directory I list above it. This is what it looks like. You start up Ushell. You standard command line terminal system, and just typing in help, you get all the commands are prefixed with .help, and you go through, you can see it does a whole bunch of things, run server, run program. There's a whole bunch of Zen stuff there. You can reset the Zen cache and check on it. Even if you're on Windows, even has some custom Visual Studio stuff in there. Like I said, this is a generic version. Ours has tons more commands just to make life easier for us, for our developers. And I can show that quickly. This time I will end the show and switch to terminal. All right. So this is clear. As I said, I can just go here, and I only have 2 tmux sessions running, but each one does have a separate. This is okay, you can't see that one. That's just the main repo, and then we also have the release 5.6 repo. So you can do .help. You can do, this is you do projects, you go between different projects. In this case, I have Project Titan. I was trying to compile that for the Zen demo, but after 24 hours of cooking, I gave up. I should have done it last week, started on that, but Lyra is also there. My project is the one, so if you just want to run it, oops. Oh, sorry. Oh, that's why it's doing that in the keyboard. All right. clear it again. So if I just want to run it on device, I just do .run. You can do a deploy game iOS, and that just pushes it to my iPhone here. I won't do that. So as I was saying, you can just do .run game iOS, and it could be Android. It could be any other platform, Windows, any other target you have, platform you have. You do that, it runs it, and it's now running on my device here. And I actually think I messed up when we restart my Zen server. Let me just that. And that's how you see. Let me just do a screenshot of this. If you do mess up your Zen, this is what you end up with. And I'll just do a screenshot. Screen. You can see that. Take a screenshot. And you get a nice, helpful warning saying that you failed to connect to your Zen server. Check your network connections. These are the IPs it's looking for, and other useful information. So this is actually really useful if you are unable to connect. And let me just check my. All right, so it is running. All right. And let's restart this again, just to make sure. Kill that. Let's stop, and if it goes well. And it is. So that's what happens when you don't restart your Zen server. So it is running on the device here. I can share that, but it will kill the console command. If you know, you can use QuickTime Player, or you can use mirroring. There you go. And there it is running on device. So you can see me moving around and doing stuff. And of course, and you can see the Z there. So it is running the Zen server and doing what's needed there. Oops, let me just change the image. There we go. But I did lose my console, so you can either stream it to your device or run it. There's one annoying bug of QuickTime. And there's other things too. So anyway, like I said, play with it. If you do like command line, if you like VI, maybe you'll like Ushell. And that's getting close to the end. If you want more documentation, you scan this QR code. It goes straight to our main Getting Started mobile development page, including 5.6 features and all the other neat stuff we have. If you are a Windows user, definitely check out the iOS for Windows. The remote build does work. So I know a lot of people, Windows people do use remote Windows and remote Mac builds. It works, though it is getting more and more fiddly. You have to make sure you know about your certificates and your profiles, make sure those are set up correctly, otherwise you will have build failures. Make sure your device is registered in the Apple portal, otherwise you won't be able to load any builds that you copy back from your Mac onto your Windows device. And the Windows does do the cooking on the Windows side, not the Mac side. The Mac side is purely doing the source compilation and the signing. And that's it. Well, thank you for coming. Thanks for coming to the first presentation.